Welcome to another lesson in math. This is a question on probability and stroke mensuration, okay, or finding area. All right, and this is the question that is derived from the paper that was written on 7th July 2016. If you'd like more lessons like this one, feel free to contact us on the numbers highlighted in green. Okay, so this is the question. It was question number 17 in that paper, and it reads, the diagram below shows a target made of a square piece of wood, ABCD, okay, ABCD. It's a square piece of wood of side 50 centimeters. Now, this is a square, it means all the sides are equal, okay? That's why they just give one side, because they know that you understand that a square has equal sides. And M and N are midpoints. So M and N are midpoints of AB and DC, respectively. It means M is the midpoint of AB and N is the midpoint of DC. That's what respectively means according to the order they are given. M is the first and AB is the first. N is the second and CD is the second. That's what respectively means. And O is the center of the square. So O is the center of the square there. Okay, of this square. O is the center. So whether you pick this diagonal DB, O will still be the center, or you take this midpoint, the line that joins these two midpoints, O will still be the center. Okay. So the question says a bullet is fired from some distance towards the target. So this is the target. Think of it like a training target for, say, soldiers, the army, in their training camp. Let's say this is their target. The question says, expressing your answer in its simplest form, find the probability that it will land in the shaded region. So when a bullet is fired from some distance, expressing your answer in its simplest form, find the probability that it will land in the shaded region. Okay, so what's the probability? What's the likelihood? That's what probability means. What's the likelihood that it will land in this region? And simply the way to calculate probability is to find the likelihood or the desired outcome, which is it landing in this shaded region, divided by all the possible outcomes. That's how we do. That's how we calculate probability. Okay, so I've redrawn this diagram. Okay, just to highlight some facts on it. So notice that from M to O there, this distance is 25 centimeters because it's exactly half of this 50. As we've been told in the question, this is it's in the middle, O is in the middle of this square. So this distance should be 25. Similarly, this distance from M to B should be 25. Remember, there's an M here, and in the middle there's O. So this distance also should be 25 centimeters. So for the two triangles, B is equal to H. Okay, so we have two triangles here, DNO. Here is an O, DNO and OMB or BOM. These two triangles, which are shaded actually, they are of the same height and base. Because remember that this is 90-degree triangle, so we use the formula for calculating the area of the triangle, which is simply half times base times height. Okay, so the height is the same, which is simply 50 divided by 2, or L, which is the length of the square, divided by 2 is 25 centimeters. Calculating the probability, the formula is number of favorable outcomes or desired outcomes, everything over total number of possible outcomes in the trial or in the situation given. Okay, so in this case, 100% of the area simply means the area of the square. That's the denominator. Okay, then on top, favorable outcomes means it should land in the shaded area. What's the area of the shaded region? That would be our numerator. Okay, or number of favorable outcomes, it's simply the shaded area. That's what we want to find. And the area of the two shaded triangles will give us the total area of the shaded region. So the area of triangle DNO, that symbol there simply means triangle. DNO, okay, DNO, this top triangle, plus the area of the triangle OMB. OMB, this bottom triangle there, will give us the total shaded area. So the formula for both is half BH. Okay, so you add the two. When you add the two, since they are like terms, remember like terms have the same letters. When you add that and that to give you 2, there are 2 of them. So just multiply everything by 2. That means you're adding. And notice that the 2, the denominator there, the inside, the 2 and the 2 outside will cancel, because when you're multiplying in brackets like that, a fraction, that number outside will always go and multiply with the numerator. So 2 over 2 will be 1. 1 times BH is just BH. And remember, the formula for the area of a square is just the length squared, which is L squared. That's what we're doing there. L squared. So BH on top, then at the bottom or geometer is just L squared. So on top, B is 25 and H is 25. So 25 times 25. Then the bottom is 50 squared. Okay, 50 squared. 50 squared. So this is the same as 25 times 25 is 625. That's your perfect square. Then 50 times 50 again is a perfect square. Will give you 25,000. Oh, sorry, 2,500. Okay, not 2,500. Yeah. Then when you divide both by 25, you get 100 at the bottom, at the denominator, and you get 25 on top. So this gives you 1 over 4. Okay, 1 over 4, because 25 into 25 is 1, 25 into 100 is 4. So expressing this in its simplest form, we can leave it as a fraction. Remember, it was probability. Although for probability, normally we express it as a decimal number or a percentage. So let's express it as a decimal number. So 4 into 1 is 0. You add the 1 to the 0, it means 4 into 10 is 2. Remainder 2. Add a 0, 4 into 20 is 5. So it's 0.25. That would be your answer. By the way, here, another way to do it, because remember this is paper 1, there's no calculator. Another way to do it is just expand this 50 times 50. That's what 50 squared means. 50 times 50. Then if you cancel out 150 there, you cancel out another one at the bottom. Okay, it will remain 2, because 25 into 50, it will be 2. Then another 25 into 50 will be 2. Then 2 times 2 will be 4. So simply 1 over 4. That would be another simpler, I think, method than getting these big numbers like this one. Okay, so we've come to the end of answering this question. Okay, and you present your answers in that format. This is the final answer. 0.25 is the probability that the bullet will land in the shaded region. That's the probability, 0.25, and you get 4 marks for that. So very good to understand your mensuration and understand the tricks to know your probability as well. Okay, come to the end of the lesson. All the best in your studies, and if you would like some more lessons like this one, feel free to contact us on the numbers highlighted in green.